That's awesome. Well, happy Monday, everybody. How's it going?
It's going well.
Oh, very good. Matt?
Awesome.
It's great to meet you, Andy. So I looked. So I have a really good friend who teaches at the University of Strasbourg in France, and I looked you up, and you're like 4 hours drive away. So you're just like right next door. You have to come visit sometime.
Sure. Come. I have a few. Announce you a little bit later so I can put some beer in the fridge.
It's awesome. Well, welcome to our show, Andy. It's great to see you. We see you a lot these days, mostly in our in the comments in our book draft. So it's good to have you on. we chatted a few weeks ago too. You're on the Data Nerd Herd, so that was a lot of fun. But for people who don't know who you are, do you want to give a quick intro?
Yeah, eventually, yeah. So I'm Andy. So yeah, I'm Andy Petrella. So so I was talking about beers and close to Strasbourg because I'm actually living in Belgium. Well, who am I? I'm originally I used to be a geospatial engineer, working in geospatial information systems, working as a data miner, data analyst, data science, whatever you call it today, right? So mainly wrangling with data most of my time, especially with vector data and the rasters, as we call it in JS, so images basically, and also in catalog. So I was like, bicéphale in a way, and and in 2012 I started my first startup, which was in construction, and ideally I wanted to use Spark already in order to do the computations. It did not work, but I learned a lot about Spark back then. So that's where also I created the Spark Notebook, which is a tool that I created to support my everyday need to do Spark and Scala when basically there were no tools for this back then. And years after doing some consulting in the Valley, I created Kensu around the idea of monitoring data during transformations, which is something today that we kind of call data observability.
Cool, sir. And for the audience out there, sorry, on LinkedIn, can you just confirm that you're able to see this show? I'm noticing that if I try and refresh my browser, I can't quite see it. So I'm wondering if that's a glitch. Anyway, back to data observability. And you came up with something that was really interesting, the Dodd method. I think it stands for Data Observability Driven Development. What is that? That seems like a cool sounding idea.
So basically, when I was a data engineer and doing some work with the data, I discovered, especially with the Spark Notebook, because I saw a lot of people starting developing pipelines and deploying, notebooks in production and stuff like that. So I said, oh, where is this thing's going on, right? So basically, there are so many things that are happening and without any control, right? And when I was observing the most, back then, is that a lot of assumptions are put in the data pipelines when you start developing. Right. So you assume that you have so many columns, you assume that you will have some certain level of completeness, you assume that you will have no null values in there, right? So you make a lot of assumptions with what people call exploration, right? And you do this during during development. Okay. And when it's done, you ship everything in production and you ship with it all your assumptions, right? And I discovered that, the bad way, right? So basically the data was blowing and I was not able to understand, which assumptions were broken because I already forgot about what happened. I have conceived during exploration. So I started thinking about, okay, what do we do in software engineering in order to avoid this kind of situations, right? There are a few things we do. One of them is conceiving some tests, of course, and plugging into your code some constraints about the data or the information you receive. Basically, when when you write an HTTP service, for instance, when you get a request and you expect to have one of the parameters to not be null, right? You assume it's not null, you check it's not null, and if it is, you throw an exception, right? at the time of development, you do this kind of logic in order to avoid problems happening. So, and these are happening during development, right? So I figured out that there are a few things coming from TDD. Of course, TDD is the perfect word, right? So when you have time and there is no pressure whatsoever, TDD is the nirvana, right, of the method, because you fix the constraints beforehand. But there are some stuff that in TDD that were interesting to retrieve and put into the data world, right? Basically fixing some constraints that can be checked by your application themselves, which are the tests, right? So DODD is introducing what we call data observability information. So information that allow you to understand the system where data is used, right? Trying to publish as much information from the system that can allow you to understand the state of the data, right? So at development time. So that includes, so nowadays, I believe most of the people know that, right? So lineage information in order to do the root cause analysis and stuff like that, metadata, profiling information, et cetera, that can be introduced at development time and used later on when you deploy in production. Okay, so that's one concept which I call contextual information. So you have the data observability information, which are published in the context of its usage, which is the application that you just developed. Well, might that be an SQL, Spark code, Python code, whatever, right? But this is the concept, right? This is one of the principles of Dodd, right? So contextual information observation. The second is synchronized. Basically, because you want to make sure that the constraints, the assumptions you've built on the data, right? When they create errors, you want to be notified about them as early as possible, right? It's like low latency detection of these issues, right? So in order to achieve a low latency, I mean, the best way to do this is to produce this kind of metrics and the constraint check when you use and you produce the data at this moment, right? Not desynchronized or whatsoever. So you have the application consuming the data, producing the data. This is the right time actually to check that your constraints as a developer, right, as a producer are matching, and then if not, you want to be notified at that moment, right? So this is what I call synchronized observability. And the last point is, in a way, it's almost the most important one, is ensure that coming from engineering like CI/CD, you have not only CI/CD for data, which for me consists in checking the logic, right? CI/CD is like checking that your logic is okay, that your assumptions are actually well implemented into your pipeline, right? But you need also some kind of continuous validation that your assumptions are still holding true, right? In production, right? So not only you want to check that you have 50, more than 55% of data, right? But you need to check it also in production, right? Because otherwise the distribution of your data may be different. You may have data drift, whatever can happen. So you want to be notified when this specific constraints has been flowed in production. So these are the three principles, right? Synchronized, so you can detect fast. Contextual, so you can resolve fast, so you know which application is to be updated, and continuous validation to ensure that your assumptions are still holding true in production, basically.
Very nice. Yeah, I mean, Joe and I have been talking about this domain a lot with a lot of our guests too. Like it's fundamentally a much harder problem than just traditional unit testing for exactly this reason, because you as the data engineer do not control the data. The data can change in random ways much faster even than an application itself can change. I guess one question I have based on some conversations we've been having recently, and that's the idea that data engineers shouldn't just consume exhaust. They should actually work with development teams to develop the schema for an application that's going to feed the downstream analytics. Could data observability also feed into development team processes, to processes for the people actually creating the data, or at least, let's say, transmogrifying the data somehow that they're getting from their users? Would that make sense?
Yeah, so to a certain dose, right? Because if you consider like a web app, right? So where people are entering some data, right? In a way, the business logic will check the correct format of the data, most probably, right? So you will check that the email is already an email or whatsoever, right? And the address as well is an address, right? So some part of the information like this is already embedded into the logic, right? But what is often missing is, for instance, how often the address is misentered, right? So this is interesting, right? It's like, how the data is injected into the system, right? But if you log and you can monitor and you can understand, that the address is really often misentered, right? You can figure out that there may be something with the form which is not behaving appropriately, right? So maybe there is a JavaScript error that screws the text that just has been entered or whatsoever, right? And in this case, yes, you can introduce some of these concepts into the applications, but it need to be adjusted also to the fact that you consume almost one information at a time, right? So it's not the data; it's one observation. It's in this case, one observation is only one event in the case of receiving the data. But ultimately, I believe that's, for me, all applications are data applications. We process information.
Yes.
Right. So it's just that amount is different, right? Even if you consider a web service, if you consider Twitter, right, it's a fire hose, right? So basically, you receive a lot of data. It's like a huge data set per se, every minute, right? So it's like ingesting data in a way from different parts, right? It's a data application. So I believe that over time, some of the concept can also shift left to software engineering, but it will not happen before it has at least appeared and strengthened into the area where data is the first matter, which is in the data engineering. So we can pass along, okay, here are the stuff that work, and here is the stuff that doesn't work, for instance, in my opinion.
Which I find really interesting because, for the longest time, I think data has been taking inspiration from software. Like data observability is just basically DevOps for all intents and purposes. But it's interesting that we'd be returning the favor in some ways. Because I feel like, I think you've been a software engineer. I've been a software engineer. I don't know if Matt has been. We'll call him. We'll give him an honorary software engineering badge or sticker. You're probably lucky, actually. But data really is not a concern when you're writing applications. It's like, does the application work? Does it pass the unit tests, right? And so data is like the last thing in your mind typically, because if it passes, if you have a calculation and you have a unit test against it, the assumption is that, if it passes a unit test, it must be right, no matter if the input data is actually correct or not, right? Functionally, the test passes, therefore it's accurate.
Yep. Yeah, in a way, you're like, how to say, a mercenary, right? So basically, you've been told to implement something, you implement it, end of the story, right? So as a software engineer, most of the time, we don't take the time to actually really understand what is the purpose of the application, understanding a little bit the business logic, right, behind it, right? So why does this person actually ask me to organize this data this way or to put it into the database that way or whatever, right? So when you actually start considering the why and not the what only, you start actually thinking about that, right? Because at some point, you will be facing the anger of the consumer that will tell you, well, the data is misformed, it's malformed, right? Or the data is wrong, right? But what does that mean to you, right? So basically, you're almost obliged to say, look, actually, I'm getting garbage in, I'm actually producing garbage out, right? Because I don't know what garbage is at the output, I cannot even figure out what is garbage in, right? And and actually, over time, when maturity, let's say that you have more and more scars like that, right? you grow in maturity, you become senior. So this is going to be a role to also understand and even challenge the business request. Oh, I want the data to be like this in database, etc. Okay, the first question you will ask is, okay, why do you want that? Right? Please tell me. Because I want to do this and this. Okay, but maybe there is an alternative. This is what a senior would do, right? Engineer in software, right? And I think this is the kind of maturity that's also happening in data, right? Because we didn't have like a lot of data engineers back then. I remember where we were like a 3 or 4 data engineer, data scientists in the company that was
around what year was this? Oh, 2000s. Yeah.
2005 to 10, I would say.
Seems about right. Yep.
So, where we were looking at Hadoop and, for big data, we were using Store, for the people who still, remember. How many bolts? No, I'm going to put a spot there. No, and we're talking about topology and stuff. It was funny, by the way, but it was very early and we were already advanced, before that we were using some talent or whatever. Nobody really cared about what we were doing and we were a few only. That means that when there was a problem, first, there were not that many people that were interested in data. So we didn't have like plenty of users like we have today. So the problem was limited in the input. And also there were not that many people that knew about that. So it was easy for them also to address the right person and also for the person to keep in mind what they've done because it was taking months and months to deploy something. So in a way, the problem was still kind of limited back then. Nowadays, you can deploy super fast and you have many people that want actually to have data. So it became a combinatorial problem actually to figure out which data is wrong and why.
Yeah, and it's just a different focus now. I mean, I think in the kind of peak Hadoop era, it was all about like how much data you have and how much you can process and how big your cluster is. And there wasn't a lot of thought given to the higher level abstractions of like, is the data actually correct?
Yeah, I don't know what you saw, Andy, back in those times, but I remember it was during the big data times where that was becoming a buzzword. But I think people like took it literally and said, oh, hey, like how big is your data? Like, do you have like how many gigs is it or how many terabytes or terabytes is actually a pretty big size back in the early back in the day. So
yeah, the 3 V's, remember that?
Yeah. Vinny, Vic.
Yeah. So it's like we have so much data that were not used. That was an issue, right? That we want to face. Okay, we have so many data there. Let's try to gather everything and to launch big jobs in order to understand what can be done with it. There was a very little effort put on the analysis per se, right? Considering Mahout, I don't know if you remember Mahout.
Oh, I remember Mahout.
Yeah. So as Ted, right? So it was Ternary and his way, right? So they are fantastic minds. They built something that was super robust on Hadoop in order to do machine learning on these things. Yep. And well, it was not easy, right? Because remember, it was like writing mappers and reducers. It was not like super easy, but it didn't, escalate that much, right? I would say that Spark MLlib made the connections, right? So, kind of make sense of using data at scale, right? And nowadays, actually, who really uses still a lot of Spark MLlib, right? So we shift actually our attention towards, okay, finally, when you can create a data mart, which is of good size, given the machine that we can have in the cluster, right? Is it still relevant to do learning distributed, right?
Right.
So I've made an analysis about big data itself, right? So a quick analysis about the interest using Google Trends. And you see that actually it has felt quite interestingly the last years in favor of analytics and using it. So it was about solving a technical problem initially. That we have a lot of data, but we don't know what's in there. We don't know what to do with it. Let's create a system that can use it, like Yahoo and Google did. but not everybody has to work on the brain, knowledge graph or a search engine internally.
Yeah, that's just it. Like someone at one of the clouds has already done that work for you. I mean, obviously, if you're at like the very bleeding edge of big data and you need to solve a very specific problem, then maybe your engineers need to focus on that. But usually it's like, yeah, just use Snowflake or Spark or BigQuery or something and focus on the quality and the utility of the data instead, and observability, making sure that you're not getting garbage data flowing into your system.
Well, I even noticed like this morning what PyTorch just announced they have a new recommender library. I mean, things are getting really simple compared to how they used to be.
Yeah.
So like crazy simple. PyTorch, I think it kicks ass. You actually got some fan mail here, Andy. You got a K, what's up? Says, hey, it's Andy. And then
Hey,
Rabbit, he says, hi, Andy. And Kate actually has a question for you. Oh, by the way, if you're on LinkedIn, not that you'll know because you can't get the stream right now because it's not working on LinkedIn, but come on over to YouTube. I posted some links in LinkedIn. So it's not the first time I've seen this problem this morning. So anyway, come on over to YouTube, join the dark side and catch up with us. But Kate has a question here. She asks, why do you say that Dodd is the right approach for scaling data usage?
Yeah. So as we just discussed, right? So basically, because we have a lot of users and a lot of pipelines and everything, right? We have more and more data, more and more reports. We have more and more stuff to govern, right? That means that if you want to govern what you produce after the fact, after development, right? I think it's too late, right? It will require more effort. So you will have to ask, your developers to add an extra step to whatever they do, right? And also you will actually multiply checks and validation points all over the places, right? Considering that you have a pipeline which is producing some data, right? If you have to deploy another application which is going to actually kind of validate that this data is kind of okay, right? You multiply your scope in a way, right? So the number of applications, the number of assets that you have to maintain, right? However, if you start introducing like directly in your application, which is running, consuming, and producing the result, you still have only one application, which is doing the extract steps in there, right, at the right time to actually validate that the data is going in the right direction. So that's actually divided by two, the maintenance, right? And maintenance means also knowledge transfer, right? Basically, if you have to ask data engineers to do some data quality, right? First, it's not very a fantastic job to do, right? So basically, they don't really like it, right? Because it's like creating tests, right? It's really like writing tests, right? Remember 20 years ago when we were asking people to write tests, people were saying, really, I'm going to be paid to write code that won't go in production? This is madness, right? This is kind of like that, right? So writing some quality checks or whatsoever for a data engineer is like not being productive. And if you have to also ask someone else to do it, right? Business users or whatsoever, right? Well, I mean, it requires some dose of skills for the consumer, right? To actually understand how to write it. And it comes only after the facts, right? That means that if someone writes a check for you as a producer, right, when something wrong is going wrong, you have to understand first what were the constraints, and then understand why it breaks, and then understand why it has actually these issues has been created. So actually, it requires more work after the fact for you as a data engineer to understand how to satisfy your consumer, right? This is why it's always better to, like anything, right? So try to understand what are the best KPIs for the consumer. You understand what you want. Okay, if we agree on this, I'm going to make sure that you are actually going to be satisfied upon these metrics, right? And because based on this, I understood a little bit the business logic, I can add my own constraints considering yours. I can create some others for me because I have to serve so many customers, right? I can actually align my own constraints. So in a way, it's more streamlined, right? It's not like I do something, I'm finishing, and then I'm going to discuss about the next step and application to actually check it. It's like I don't know. It's more natural for an engineer to add logging and monitoring when they code and not after. In a way, does it make sense? I hope.
Well, and it just makes more sense in general, right? Like engineers fundamentally don't want to be doing a lot of manual work. They do want data quality. They want to use tools to get there, right? They want to automate. And kind of to what Joe was saying just a minute ago, things have gotten so much easier. If that's the case, we should be getting a lot more done, right? And yet it's often these like really fundamental issues of data quality and data observability that are tripping us up. And so combining automation with all these modern, really powerful tools is a huge opportunity, I think.
Yeah, and we always relate data observability with data quality, which is one of the the main use case, of course, right? But there is something when properly done, which is interesting as a side effect, right? So there are two things. First, I always say that data quality is always a conception of the user, right? Basically, you can do whatever you want. The quality will always be something that is estimated by the user. You can try your best to match as much as possible the expectations. The other is data definition. I'm always actually how to say. I'm always scratching my head with data definition. I have to give a definition to my data. Well, actually, so I want to understand what is actually in the data, but depending what I'm going to do with it, it's going to have a different definition, right? A data an address can be just an address, it can be a home address, it can be a billing address, it can be whatever, right? But the way you're going to use it is going to change it, right? And what is actually defining the purpose of a usage is the application which is doing it, right? So which is consuming and producing it, right? So when you start observing the way the data is being used, you can start kind of clustering, the way the data can be used too. So you can assign what I call facet definition to the data. Okay, this is an address, but it can use also for billing. Okay, this is an address, but it can also be used to send some coupon bonds for marketing purposes, etc., because there are some how to say pipelines that are using it. And if you see an address somewhere which is used for some use case that you haven't been using your data for, you can actually discover new use cases for your information, right? So in a way, I mean, what I'm describing here is like a knowledge graph, right? So it's something that has been used forever by Google, right? Using page ranks, right? So basically, depending on how you use the words, it will have a different meaning, right? I believe that actually data has the same concept embedded that can be reused as long as you can observe the links between the data, which is the fundamental concept used by PageRank, by the way.
It's interesting too, because it's almost like a context graph in some ways too. Like you started getting me thinking about. I mean, there's been data dictionaries forever, which I think tend to capture the semantic definition of something. But then there's also now like this new. I wouldn't say it's new. Looker's been doing this for a while, but a metrics layer. And then, but what I think you're driving at is it's a very interesting point that had me kind of doing one of these things when I'm deep in thought, which is the like a context layer, really. So what's the context of how this data is going to be used? Because so often, and you've been an analyst and a data scientist, so I'm sure you know this. When you bring solutions to people, they're like, well, but you're looking at the data in the wrong context, right? Like this, you're looking at it the wrong way. Wrong way tends to imply a context, right? So
exactly.
Sometimes it can be a bit of like bullshit bike shedding, kind of deflecting, like look over here. But in a lot of cases, though, I think there's some truth to this kind of stuff.
It's what we call ontologies, actually. So you have ontologies which are composed of concepts, right?
Yeah.
And the same concept can be different themes, right? And depending, from which theme you look at the concept, you will understand it in different fashion.
Yeah.
Right. And so this is something that comes from semantic, RDF and stuff like that. That is interesting. But yeah, and again, so it's embedded into the word embedding also, right? So when you consider the word embedding algorithms, right? It's also the same thing. It actually encapsulates the context of usage, right? And depending, which context you are, the word embedding will actually give a sense to the sentence, to the words. Same for the data, I mean.
Interesting. Quite interesting is how many of these concepts are now sort of intertwining with each other, right? So I know back even a few years ago, things like context ontologies weren't being discussed in the context of like data quality, for example. Well, data quality wasn't really being talked about either. It was kind of like, yeah, that's somebody else's task. So that's interesting.
Yeah, it was. Data quality was like, okay, the person who is going to use it will tell me when there is a problem. Right?
And of course, many problems they won't see, right? There are problems they'll detect, and there are others that they'll just have no idea.
Yeah, exactly.
Yeah, kind of like StreamYard and LinkedIn right now.
But if you consider a food supply chain, right? If at the end you are the guy who is eating the sushi, you don't want to be the guy actually who tests the whole chain before, right? And even
not
if
those 50% off chains either, not the cheap ones. That's interesting. Oh, what were you saying? Yeah, I've been thinking about sushi now. So
Joe's had breakfast.
So it's a little bit early for you, though.
Yeah.
Depends. You get the 50% off sushi at about 9:30 a.m. in my time, so works out well. Rabbit actually has a question for you. What's up, Rabbit? I think you guys have met each other before. Where does Andy see data observability space in the next 2 to 3 years?
Yeah, well, observability will be it's going to be part of classic, let's say, data platforms in a way, right? So it's more like best practices, right? So we did at some point in time CI/CD because, well, I mean, it was required to make sense of tests, right? If you have no CI/CD, you don't write tests. Why? Because then, look, I mean, they work on my machine, so I run the test on my machine, so it's fine, right? So I can deploy in production, right? So CI/CD was meant, okay, so I'm going to run the test elsewhere, and if it works, I'm going to deploy them, right? Nowadays, testing the data during exploration is not enough, right? Because otherwise you cannot scale. You cannot go in production without any test. So we need to, in a way, introduce this in order to make sense of the best practices of validating and creating constraints. If you don't have anything like this, there is no point of actually working with your business users, creating SLAs, SLOs, whatever. If you don't have something that actually sustaining it, creating the value out of it, you still have to do everything manually. What's the point, right? So in a way, it's going to go. Actually, I think it's going to split sometime at some point, right? So some part will be closer and closer to observability solution, overall, because in a way it's like a vertical. So it's like observing a system. You want now to understand the data component of the system, right? So it's going to merge with observability, and the capacity to produce the right information. This is the other part of the brain, let's say, that will get closer and closer to the applications, the database, data warehouse system, and so ever, right? So they're going to be more and more responsible for producing the right data, and information will be consumed in a more global context, than only the purpose of data. I don't think it's going to take only 2 or 3 years, because it might not be enough. But I believe this is the path that it should be. That should be for data observability. Yeah.
Okay, so here's a question that sprang to mind just now when you're talking about SLAs. How would we define first of all, a KPI for data quality? In other words, can we formally define metrics where we say, this is how we're doing across the business on data quality? And can you almost define an SLA for data quality where you say, okay, if we fall below this threshold, we're not meeting our expected service level, and that happens this percentage of the time, just like you would with an application. I mean, with data, it's not adequate to just say the data is flowing if it's garbage, right?
Yeah. I think that we already do it somehow.
Yeah.
because if I remember, right, so either we're writing Spark code or writing my SQL or SQL or whatever when I was using Cassandra or AQL with other, whatever, right? So the language I was using, before moving to production, I was doing some test and validation, right? So I was already kind of running my queries, running my job, looking at the results, saying, looks okay, right? So I had already a few kind of algorithm constraint check whatsoever that was running in my head that was actually validating that I was good to go, right? So it doesn't mean that there is yet SLAs, right? Because sometimes actually there is a bias. I am the engineer. I think I understood properly what I need to produce. The result seems okay. I'm going to production, right? So I believe that that there is a first conversation that needs to happen where the data engineer can ask, okay, if I do this, will it be okay? So if I produce this kind of result, will it be okay? Yes or no? Then they can agree on something, right? It's not like, okay, I think it's okay, then I move on, right? Because I think I understood properly. So in a way, we already do this, but we're not what we call reifying it, right? We're not creating it somewhere, right? So it's like creating a proper constraint, a proper check or whatsoever. So yes, in a way, that's the way I would do it. And if the person has no idea how to qualify the data, right, the consumer, then there is a problem. There is a problem because you don't know how to satisfy the person. Then there is collaboration that can be done using profiling, for instance. Okay, look, we're going to do a few tests. I'm going to profile the output or the input or whatsoever. We're going to look at the results and you will tell me if it's okay or not. And based on this, we can set threshold rules, whatever you have in mind, right? And then you come back to it over and over in order to make sure that it's proper. Otherwise, the thing that will happen, and I guess you've been there, the consumer will come to you and say, the data is wrong. Right? If they don't say anything else, right? So when they're gentle and they're still not that angry. And what does that mean, wrong? So has it been okay since then? So how long has it been wrong? You don't know, right? So basically, the new thing that you have, it's wrong, and I need it now, right? So basically, you have no time to fix it. I just want it now because I kind of acquire a service from you to have the data, right? I'm expecting you to have it correct, but what does it mean, right? The only thing that happens afterwards, if there is no this discussion on the SLAs, whatever you call them, is like I like to call them just objectives, right? So something that needs to be attained, right? So that you reach a certain level of objectiveness, when it comes to look at the data. So basically you introduce it earlier, and yes. So what was I saying about these objectives? Is not. It's, for me, it's something that exists already in a way. It's just that we don't write it down, or even writing it down. Is it really interesting to write it down? These checks needs to be actually validated continuously, right? So not only once, every now and then, not because I don't know, at some point the data is wrong, then your consumer is angry, so you discover why, and because you have no system at place, that will actually help you avoid this kind of situation later on, you're going to put the burden on you. You're going to come a little bit earlier in a job or doing it during lunch or whatsoever. You're going to do, I'm going to check my data, time to time, you do it, right? But the more consumers you have, of course, the more this job is actually growing, and the more your frustration is actually growing too. I'm talking about this from the R, right? Because basically I've been there probably too often.
Yeah, this totally makes sense. And I think what I'm getting here too is that, like, until you have this prerequisite of data observability, there's not a whole lot you can do about an SLA. You're just going to hear, your data's wrong, people will be angry. But once you have that prerequisite, then you can start defining KPIs, SLAs on top of that. Yeah, that totally resonates with me. And yeah, again, I've totally been there, just like Joe has. So.
Yeah, and if they have no idea, as I said, right? So tell me what you want to do with the data, right? Just explain me, and then we'll figure out together, right? But
That's interesting. What are some anti-patterns with data observability?
Yeah, it's very new, right? So I would say trying to reuse what I mean, there are two anti-patterns that I see out there, right? So coming from the data quality monitoring angle, like we have problems with the data, okay, we're going to monitor it. Okay, I mean, okay, it can work, right? But the more data you have, the lesser it's gonna work, right? And the more consumers you will have, the less it's gonna work also, right? Because you cannot actually satisfy everybody with a kind of monitoring that will actually ping the data time to time, right? Again, time to time is hard to define because you may have different consumption patterns, so you don't know, you have to synchronize, the checks and everything. So I think that this is an anti-pattern, first, because you will only know if the data seems to be okay generally, right? And if you have too many constraints, that is going to impact your ecosystem, your system too much. And also, it's only observing the data itself. So if at some point you detect that there is something wrong with the data, you still have no clue why, right? And you still don't know, who is impacted, et cetera, right? So in order to recover this kind of visibility, you have to try to do some reverse engineering, right? Taking some logs from application, et cetera, in order to try to say, okay, look where this SQL was coming from, et cetera, to understand, what are the impact of this data quality, and what is the root cause in a way, right? To me, it's like a patch on a big problem. Okay, so it's like, we would never have had it testing in development. I don't say that everybody is testing, right? But everybody feel like going in production without any testing engineering. Okay, so if there is a kind of culture change, right? So basically, putting it at the right level at the right moment, to me, is the way to go. So doing it from the outside work is not observing, is checking, monitoring, basically. It's like, so the analogy I take very often is what we expect from a car manufacturer nowadays. You go to the garages like every month in order to check if your car is okay, or you expect to have a sensor in your bloody car that will tell you when something is actually going fishy, right? So that's two different things, right? Because you don't want your car to stop in the middle of the highway, something you haven't, checked properly. That's for me one of the biggest problem, is try to do it as a patch. Like, okay, we're not going to ask anything to anyone, and actually we try to do our best in the best effort, right? But all the events, because generally data quality, data issues, etc., right? I always weak events, weak signals, right? It's not something that happens very often, right? So because there are weak signals, there are a lot that you will not be able to intercept correctly, right? That means that the whole system is going to be in jeopardy because people will have disbelief into it, right, at some point. And it still requires a serious dose of involvement. This is a big, I think, anti-pattern that I see nowadays in data observability. Well, there are others, and I think this one is a big one. Oh, there is also something that I was discussing with a friend of mine recently. I'm still trying to figure out, right? Is anomaly detection.
Is what? Anomaly detection?
Anomaly detection.
Yeah.
Right. So again, not asking anyone to do anything, right? So, don't bother. We'll have enough information to actually detect the problems. It's a nice feature, right? So it's nice. So this is the future of anything, right? But again, we are talking about weak signals, right? That are happening rarely, right? So we have no level data. We have no, real insights about how to detect those properly. So I'm afraid of getting into some kind of alert fatigue, right? Still lowering the value of the whole system that you put in place, right? because again, you didn't want to actually educate your people, involve them into the process of thinking about what they will get out of it, right? It's like nowadays we would deploy ELK. The log will happen automatically, and it will tell me when there is an error I need to figure out, right? But I don't do anything. I mean, this thing exists for more than 15 years, right? And we're still not there, right? So I believe that the anti-pattern here is to not involve people more, and trying to say, okay, we know that the data observability is not cute, is not funny, right? So we're trying to do everything automated, but I've been there, right? So it's going to create some over-promise, to be honest, because that's the way it is in a way.
With anomaly detection for data quality, for example, I mean, would you tend to skew more towards more false positives or more false negatives in this case?
There will be it depends the threshold you put, right?
Yeah.
So basically, so you will end up with a lot of false positive. Yep. Because we have a data quality tool, so we're going to put the bar very high, right? And then you'll get a lot of false positive, and even worse than that, because data quality is a conception of the user, right? It can be a false positive for someone and a true positive for another one, right? So and it's hard to segregate, right? It requires a context of usage in order to understand if it's really a true or false positive. So then you need to embark this information also in your model, right? And almost build different models based on the context. Okay, but when you end up in this situation, of course, the first thing you do is to diminish the sensitivity of your model, right? And then you end up in the other bucket, where basically either you get nothing, right? Or worse, through false negative then, right? So basically, you don't see them anymore, basically. So I think, considering the amount of alerts that we actually shut down, even something that is manual like Joe Reis and so forth, right? So actually, we shut down the alerts, and this thing is not even automated, right? So I imagine that it will be first and then second.
I mean, I think one of the main tricky things about anomaly detection is that you may be detecting a data quality issue, or you may be detecting a change in the world. You may be detecting a change in your inputs. That's very true too. And both are worth investigating. And like you just said, Andy, which one is quality is kind of in the eye of the beholder. Is it a quality issue, or is it just the world changed and you need to go and investigate analytically?
Yeah, that's a really good point, actually, too. I recall in my career more as a data scientist or an analyst, even like my job was forecasting, and I was, we experienced. I remember getting hired at one company in August of 2008, and then September 2008 happened, and that was when the financial bottom fell out of the entire world. And so your ability to forecast kind of changes a bit. So the signals that you might wanted to use back in the day don't apply anymore. So.
Yeah, that leads also to, when do we have to retrain our algorithms, right?
Mm-hmm.
So when the data is changing, it can give you an idea that you need to retrain your model, because the word that used to be seen by the algorithm before actually has changed too much, and you need to change your model, right? And that you don't have to retrain your model because the data is of bad quality, though.
Well, yeah, right? I was going to say, because there's a certain point where I think you have to be wise enough to know retraining this model is not going to help either. Like everything's changed. Like the world changed last Thursday, right? For certain places, and so.
Well, like at the start of COVID,
pretty much everything.
Your anomaly alarms are going to go off, right? Like all your financial transactions just sort of collapse for a while. And yeah, you can't predict the future from that point, because who knows what the economy is going to look like over the next several months, just like you were saying, Joe. It's a very similar situation, just a bit more recent.
Mm-hmm. Yeah, it works until it doesn't. But that's a general rule for like everything. So just kind of switching gears a bit. I mean, tell us what else you've been up to. I saw you came out with an O'Reilly radar, if I'm not mistaken, a bit ago.
Yes. So I released recently a small report on data observability. originally I was talking about AI winter and stuff like this, AI winter, which is something that I'm fearing a lot because of the over premise and this kind of a misconception of data quality or quality overall from the business users, right? And apparently it has been well received. It's more report. So now I'm going to write a full book with O'Reilly on the fundamentals of data observability, where I'm going to less cover the what and why of data observability, but more the how. Okay, how, we're talking about SLAs, how do you define them and so on, right? So this is the first step of the how, but also how do I actually implement it? What kind of information? How do I get it out of, I don't know, BigQuery, Snowflake, Spark, Airbyte, or DBT or whatever, right? So it's like some recipe in order for people now to, stop talking about it, but do it, right?
That's an important point. Real important point. It's interesting too. I want to walk through your thinking on this because like we're both O'Reilly authors, and you're actually helping us review our book right now. Thank you very much. Sorry for
thank you.
subjecting you to the endless abuse.
It's a lot of words. It's a lot of words.
It's a lot. Yeah, I think we threw one chapter out. You were like, "What?" Wait until you get to the next one. By the way, it's like 60+ pages. But yeah, I mean, walk me through this because data observability is a fairly newish field. How do you make exercises and material that's going to be relevant by the time the book goes to press, let alone in a couple of years after?
Yeah, it's a good question. Because the how also requires some know-how in a way, right? So basically, it's not only for this and this technology, here is how you do it, right? But also it's like a framework, right? So how do you get information? Like what kind of information, from where it comes, how you interpret it, how you create, how you digitalize it almost, right? So it's really about is also a kind of meta framework, if you want, right? So if you have a technology like this, then this is how you can intercept the lineage, the metadata, etc., right? So in order to make it relevant also for the next technologies that will happen afterwards. So then there will be, of course, the recipes that will be technologies by technologies, so the people actually can use it as a cookbook. But the blueprints will be in a chapter before explaining, okay, if you have a SQL database, here are the big concepts. Here is how the information should flow in, and then later on, okay, here is for Snowflake, Postgre, etc., yeah. So this is how it's going to be framed in order to make it relevant. Or we will also add some addendum and version 2, version 3 in order to complete it with other technologies that will pop up eventually. But because I believe that it requires some dose of community around, like as I call this, like agents. When you consider open tracing, for instance, I mean, you have multiple implementation depending on the language whatsoever. They're not respecting the same patterns in a way, but fundamentally the principles are the same, right? For data observability, the same, right? And this is a spoiler, but in there I will have also a recommendation even for database engines producers, like
Cool.
for Spanner, BigQuery, Postgre, etc., what they can do at the database level, which is for me only nothing but just a data application also, right? When you consider it this way, it takes text and then proceeds execute it on some files and then return the results in application, right? So what they could do in order to return information. The spider is nowadays, they are very complacent by returning, for instance, the number of rows, right? So when you issue a query, you get the number of rows, which is one information, right? They just process the data, right? So why don't they actually get us also some distribution information about the data they just processed? The lineage, what are the data that were consumed, the fields, and so on and so forth, right? They have all this information. We have to retrieve it, whilst actually they just have been processed, right? So this is the kind of actual recommendation I would give to database vendors, for instance.
That's really cool. Yeah. Yeah, we'll happily help you review this book since
Yeah, more than happy.
we have a feeling of reciprocation here. So that's awesome. Yeah,
More
I
than
mean,
happy.
what's that? Yeah, of course. So yeah, that's awesome. Cool. I think we're coming up on time here. For people who want to learn more about you and Kensu, how would they do that?
They can, follow our page. They can go on the website. They can ping me on Twitter also. Kensu IO on WhatsApp. Also, we're going to, excuse me, we're going to open what we call the sandbox. So it's like a free of use version of our platform, right? A bit stripped in order for people to try it, right? So to try it with Python, Spark, BigQuery, whatever, right? So they can try and see, what does what can data observability do for them, right? So because I believe now is the time where people experiment it and not only talk about it, right? So that's why we do this. It's like what we say in French is getting out of the busk of the wood, right? But I think this is the right moment. So if they're willing to try a little bit to experiment it, to give some feedback about how data observability would help them in ongoing fashion, they can contact me or directly our website.
That's cool. Awesome. Well, thanks for coming on. It's always good. And also on the Data Nerd Herd, we have a podcast actually where you and I chatted for an hour about all things data and everything else. So I had a lot of fun with that chat. We're actually going to try and post the video. We can run into this weird glitch where it was only like 60 minutes of Andy talking, but you could also hear my audio. So if you wanted to see like a 60 minutes of nonstop Andy just looking like he's being interrogated, this could be might be a fun one.
It's a Joe party.
It's the Joe party. Yeah. But yeah, what else we have coming up this week? We got actually another Data Nerd Herd episode with Matt Turk. You may have seen his data landscape
it's going to be fun.
It's a good conversation. We actually talk about stuff that he never gets asked, which you'll find out more about. Nobody seems to ask him about investing, which is kind of interesting, how he invests and whatnot. They always ask him about the data landscape, and he's like, I really want to talk about investing. I'm like,
can he talk about all the products on the data landscape? No, actually, please don't.
Yeah, that would be like a 1,000-year podcast. That would be like did you ever listen to Dan Carlin's Hardcore History podcast back in the day? His episodes would be like 6 hours long. And a 4-part series.
I mean, to be fair, a lot went on in history and a lot goes on in the data space. I just don't always want to hear about it on a podcast. So.
Yeah, it's pretty crazy, but stay tuned for that. Also, our friend Kate, Dedicated, she's actually got her Dedicated conference going on tomorrow, so go check that out. If you happen to be in Salt Lake, you're going to have to flip a coin because you can also go to the Snowflake's Data for Breakfast with Matt and I. We're going to be there representing Ternary sponsoring Snowflake's Data for Breakfast in Salt Lake City. I guess go to Data for Breakfast for Snowflake, Google that and get more details and register. I think we're past peak registration, but feel free to crash it anyway. We're going to be doing a 90-minute workshop, Zero to Snowflake. So that's going to be a ton of fun. So going to need a lot of coffee to get through that.
Zero to Snowflake means going minus, right? I guess.
And temperature wise, yeah. Zero to exactly. It's a mind bender.
What system you're using?
Depends on what system you're using, but that should be pretty good. So, and then what else here? This Friday, actually, we have kind of a rebranding of the show. We used to call it Let's Talk Data Engineering. I think I'm going to call it like TGIF, Let's Talk Data, or something stupid like that. But we got Nick Schrock, the co-creator of GraphQL and the creator of Dagster, along with Scott Breitenother from Brooklyn Data Company. They're going to be on to talk about Bundlegate. So there's been some articles coming out recently about the bundling and unbundling of Airflow and what that means for the data community. You might want to check these out. Yeah. But anyway, we're going to get these guys on to talk about that. Next Monday morning data chat next week, we have Fabiana Clement from Y-Data. We're going to be talking about synthetic data. So that's going to be cool. She's super knowledgeable about that space. So yeah, lots going on. But again, Andy, it's always a pleasure to talk to you. And whenever Matt makes it over to Strasbourg, he can buy you a many beers.
Many
to,
beers. I think one beer per page that you reviewed or something like that, maybe.
You're gonna need to buy him a new liver while you're at it too.
I mean, 60 pages long chapter is going to put me on my knee, right?
Yeah, that's chapter 6.
And chapter 8.
Oh, chapter 8's that long too, huh?
Oh, it's 70 pages. It's like I think we anyway.
Yeah. Anyway,
it's going to be a great book. So I keep talking about it everywhere I go, by the way, because I believe that it contains everything that someone needs to know, right? So they don't have to go to uni anymore. Right? They're just read this book is okay, right? So I mean, to be honest, it's clear. It's full of pragmatic points, and it goes in all directions. That needs to be understood for a data engineer, and not only like SQL. Okay, here is SQL, right? Here is how you do a group by and having. No, it's only about this, which I appreciate the effort they put there, because it's a lot of work.
Yeah, what we tried to do with this book, though, we wanted to, because when we were asked, okay, so write a book about the fundamentals of data engineering, we're like, kind of like you, where it's like, okay, you have to step back and understand what, in the next 5 years, like what's not going to change, right? Because it would be easy to write a book, data engineering with Spark. Like that's easy. That's probably been done a million times. Just take a step back and really understand the breadth of the field and say, okay, like this is what we think data engineering is now and for the next 5 years. Like that was a hard exercise. The book proposal, I think, was still the hardest thing we went through, just thinking through it. But as you know, it's that ain't easy either. Yeah. So, but yeah, thanks a lot. I do appreciate it. And yeah, definitely, it was coming from you, especially like somebody I think is at the top of the game, in data, and you're one of the most original thinkers I know in the space, and from a technical and strategic standpoint. So definitely appreciate the compliment. It means a lot
for having me.
Yeah, of course, anytime. So, and next time we have you on, hopefully LinkedIn and StreamYard actually work. So appreciate the people that have stuck with us on YouTube. I'm going to post this over on LinkedIn when we're all done. So awesome, man. Well, until then, we'll see you next time. So have a good day.
Thanks a lot.
Yeah, thanks. Bye-bye.
Have a good one.